The puzzle of human mastery has fascinated philosophers, psychologists, and educators for centuries. Is greatness born, or is it made? On one hand, history offers examples of child prodigies who astonish with seemingly innate brilliance. Mozart composing music at an age when most children are learning to read, or Ramanujan producing extraordinary mathematical insights with little formal training. Stories like these feed the belief that talent is a gift of nature, bestowed unevenly and setting a few apart. Doesn't it seem as though some people arrive in the world already wired for genius? Yet research into skill development paints a different picture. Studies of expert musicians, athletes, and scientists show that deliberate practice, focused, sustained, and effortful training can elevate performance to extraordinary levels. The famous 10,000-hour rule, popularized by Malcolm Gladwell, suggests that mastery is more about accumulated practice than innate ability. Tiger Woods, for instance, spent thousands of hours honing his swing from early childhood, and elite violinists typically log far more structured practice hours than their less accomplished peers. Could it be that genius is not something you are born with, but something you build? Stroke by stroke, note by note, experiment by experiment. The paradox deepens because talent and practice are not easily separated. Natural ability can accelerate progress, but without practice, it withers. At the same time, intense practice can compensate for only so much. Most of us, no matter how many hours we train, will not become Einstein or Serena Williams. Modern neuroscience adds nuance. Brain plasticity shows that practice literally reshapes neural circuits, but genetics also predispose certain individuals to learn faster, endure longer, or adapt more efficiently. So, is mastery the result of practice working on a brain that is already primed by talent? Or is talent itself just early evidence of practice-like effects unfolding more quickly? A lesser-known insight is that context matters as much as individual effort. Opportunities, mentors, cultural support, and even luck often determine whether a talent is noticed or nurtured. Ramanujan needed Hardy to bring his insights to the mathematical world. Without that recognition, his genius might have remained obscure. Similarly, countless skilled individuals may practice diligently, but never achieve visibility or impact because the stage was never set for them. Doesn't this suggest that the nature versus nurture debate overlooks a third factor? Environment? The paradox, then, is that genius appears both innate and cultivated. Talent without practice stalls. Practice without some spark of aptitude struggles to reach the highest levels. Out of this tension emerges a more holistic picture. Mastery is not nature versus nurture, but nature through nurture, shaped by opportunity and persistence. The lingering question is whether genius is a rare flame lit at birth, or whether it is a fire that anyone can kindle with enough fuel, which feels more unsettling. That greatness is reserved for a few, or that most of us may never test the true limits of what practice could achieve. For centuries, mastery in art, science, or sports was attributed to inborn talent. Gifted individuals were thought to possess innate abilities beyond the reach of ordinary people. This perspective emphasizes natural intelligence, creativity, or physical coordination as the root of achievement. Classical philosophy and early psychology often described genius as a divine gift, rather than a product of effort. In this framework, practice merely reveals what is already present. Talent is seen as destiny, and effort plays a secondary role. Yet this view cannot explain why many highly talented individuals fail without discipline. It presents talent as the primary determinant of mastery. Mozart was celebrated as a prodigy, composing complex works as a child, seemingly without years of formal training. It is like a seed that already contains the blueprint of a towering tree, needing only soil to emerge. In contrast, Modern psychology highlights deliberate practice as the key to mastery. Studies suggest that consistent, targeted effort over thousands of hours leads to expertise, regardless of initial talent. This view emphasizes perseverance, feedback, and incremental improvement as the real engine of success. Practice shapes the brain through neuroplasticity, creating pathways that support complex skills. From this perspective, genius is not born, but built through dedication. Talent may help, but practice defines outcomes. This approach democratizes mastery, making it accessible to many. Violinists who reach world-class levels often log over 10,000 hours of structured practice. It is like sculpting marble. Raw stone may differ, but the repeated chisel blows create the final masterpiece. Science reveals that genetics do play a role in shaping ability. Certain genetic profiles affect memory, muscle composition, or processing speed, giving individuals a head start. Twin studies show strong heritability in cognitive ability, musical aptitude, and athletic performance. These traits can influence how easily skills are acquired. However, genes set potentials rather than guarantees. Even with favorable biology, without effort mastery often remains unrealized. Talent is thus an important but incomplete factor in explaining genius. Elite sprinters often carry variants of the ACTN3 gene, associated with fast-twitch muscle fibers. It is like having a high-performance car engine. It offers potential speed, but only training and maintenance unleash it. Practice rewires the brain by strengthening connections between neurons. Repeated effort leads to myelination of neural pathways, making skills faster and more efficient. Deliberate practice focuses on weaknesses, forcing the brain to adapt in targeted ways. This explains why hours of effort yield measurable structural and functional brain changes. Talent may set the initial map, but practice builds the highways. Neuroplasticity turns repetition into expertise. The capacity for change proves that mastery is not fixed at birth. Brain scans of pianists reveal enlarged motor and auditory regions developed through years of practice. It is like paving dirt trails into highways through constant use and reinforcement. Talent and practice rarely act in isolation. They interact dynamically. Talent may make practice more efficient, as gifted individuals learn faster or find it easier to stay motivated. Conversely, extensive practice can uncover hidden talents that would otherwise remain dormant. This interplay complicates the search for a single explanation. Neither talent nor practice alone accounts for the diversity of paths to mastery. Instead, they form a feedback loop, where strengths guide practice, and practice sharpens strengths. The paradox arises from this inseparability. Tiger Woods displayed natural golf ability early, but also practiced obsessively from childhood. It is like fire needing both fuel and oxygen. Without one, there is no flame. Popularized by Malcolm Gladwell, the 10,000-hour rule suggested a fixed amount of practice guarantees mastery. Later studies revealed the picture is far more complex. While practice is crucial, its effectiveness varies greatly depending on individual differences. Genetics, motivation, and quality of training all modify outcomes. Some achieve mastery with fewer hours, while others plateau despite greater effort. The rule highlighted practice, but oversimplified the balance with talent. It illustrates how seductive simple formulas can obscure complexity. Chess masters often exceed 10,000 hours of practice, but not all reach grandmaster status. It is like believing every tree grows to the same height after 10 years. Environment and genetics matter too. Beyond talent and practice, motivation and opportunity shape mastery. Grit, the perseverance to sustain effort despite setbacks, often distinguishes those who succeed. Social context, mentors, and resources also create conditions where practice is possible. A naturally talented child without support may never progress, while a moderately talented child with guidance can thrive. The paradox of genius thus extends beyond biology and effort to environment. Success reflects not just what is inside a person, but what surrounds them. Talent, practice, and context all intertwine. Serena Williams' success in tennis reflects both extraordinary ability and relentless dedication, guided by early coaching opportunities. It is like growing a flower. Sunlight, water, and soil all matter as much as the seed itself. Different cultures emphasize talent and practice in varying proportions. Western traditions often romanticize the idea of innate genius, celebrating child prodigies and effortless brilliance. Eastern traditions place greater emphasis on discipline, repetition, and respect for practice as the path to excellence. These cultural frameworks shape how individuals interpret their own abilities. Beliefs about talent can inspire confidence or discourage effort. Likewise, belief in practice can sustain perseverance even without immediate results. Perceptions of genius reflect culture as much as science. In Japan, mastery of traditional arts like calligraphy is celebrated as the product of lifelong disciplined practice. It is like two lenses focusing on the same light. One highlights its source, the other its shaping. The paradox lies in the interplay between natural ability and sustained effort. Talent without practice often fades, while practice without talent may plateau. Yet in combination, they produce outcomes greater than either alone. Genius emerges not from a single source, but from the dynamic tension between nature and nurture. Science shows both elements are indispensable, but disentangling their relative contributions remains unresolved. Mastery is both gifted and earned, both inherited and built. The paradox endures because the truth is inseparable. Albert Einstein showed profound natural intuition, but spent decades rigorously developing his theories. It is like music. Notes exist naturally, but only practice arranges them into symphonies.